Hello everyone, welcome to the Mathematics MI channel. In this video, we are going to solve this interesting integral. Integral from 0 to pi over 2 dx over cube root of 1 over 3 plus sine square of x. And the answer is cube root of 3 gamma raised to the 3 power of 1 over 3 over cube root of 2 to the 7 times pi. Well, how to begin? Okay, first I'm going to take a substitution. Here we have sine square of x. So I'm going to take sine of x is equal to hyperbolic tan of theta, hyperbolic tangent of theta. Then when we differentiate, we have cosine of x dx is equal to, we know the derivative of hyperbolic tan is equal to hyperbolic secant square of theta d theta. Well, here we have cosine of x. So we know cosine of x is equal to the square root of 1 minus sine square of x times here dx is equal to hyperbolic secant square of theta d theta. Well, here we have sine square of x. So we know sine of x is equal to hyperbolic tan of theta. So we have square root of 1 minus hyperbolic tan square of theta dx is equal to hyperbolic secant square of theta d theta. Okay, we know 1 minus hyperbolic tan square of theta is equal to hyperbolic secant square of theta. So we have hyperbolic secant square of theta dx is equal to hyperbolic secant square of theta d theta. Okay, then here the square root of hyperbolic secant square. So we know this part get cancelled. So we have dx is equal to hyperbolic secant of theta d theta. Okay, then we can plug in to our integral. So we have now we know the limit, lower limit when x approaches to 0. We have theta approaches to also 0, and upper limit we know infinity. Then dx we have here hyperbolic secant of theta. So hyperbolic secant of theta d theta over here we have cube root of now 1 over 3 plus sine square of x. We know hyperbolic tan square of theta. Okay, here then we know here hyperbolic tan square of theta we can convert as a hyperbolic secant function. So we have here integral from 0 to infinity hyperbolic secant of theta d theta over here cube root of 1 over 3 plus we know this is equal to 1 minus hyperbolic secant square of theta. Okay, then here we can simplify 1 over 3 plus 1. So we have here 0 to infinity. So here 0 to infinity hyperbolic secant of theta d theta over here cube root of now we know here 3 plus 1, so 4 over 3 minus hyperbolic secant square of theta. Well, we know triple angle formula of hyperbolic cosine. Hyperbolic cosine of 3x is equal to 4 times here 3 power x minus 3 times hyperbolic cosine of x. Okay, then each part I'm going to divide by 3 times hyperbolic cosine raised to the 3 power of x. So here we know only 4 over 3, then minus here 3 times hyperbolic cosine of x over 3 times here 3x. Okay, then we know we can simplify. So here we have 4 over 3 minus here cos hx. Here we have hyperbolic secant square of x. Okay, now here we have same function, so we can write here integral from 0 to infinity hyperbolic secant of theta d theta over here cube root of now here we have hyperbolic cosine of 3x over 3 times hyperbolic cosine raised to the 3 power of x. Now we have here 3 1 over 3, so we have cube root of 3. It's a constant, so we can take outside of the integral sign, and here 0 to infinity. Now we know here cube root of hyperbolic cosine raised to the 3 power, so we have 1 over hyperbolic cosine of x, so hyperbolic secant of x. So we know this part also get cancelled, this part also get cancelled, so we have d theta over here cube root of hyperbolic cosine of 3 times theta. Okay, then here we can write this is also equal to cube root of 3 integral from 0 to infinity here hyperbolic cosine raised to the minus 1 over 3 of 3 times theta d theta. Okay, now to evaluate this integral, I'm going to take a substitution. 3 times theta, so 3 times theta is equal to u, so 3 times d theta is equal to du. Then we can plug in, so we have here cube root of 3 limit also 0 to infinity here hyperbolic cosine raised to the minus 1 over 3 times theta we know u, then d theta we know du over 3, so 1 over 3 we can write outside of the integral sign. Okay, now our integral I, so we have now I becomes 3 times square root of 3 over 3 integral from 0 to infinity hyperbolic cosine raised to the minus 1 over 3 of u du. Okay, how to evaluate this integral? Now we have another interesting integral. Well, let's take this integral is equal to j, so let's evaluate j. So I'm going to take the general case integral from 0 to infinity hyperbolic cosine raised to the minus s, here real s greater than to 0 x dx. Well, how to begin? Okay, first I'm going to write here 1/2. Now I'm going to change the limit minus infinity to infinity. Then hyperbolic cosine of x we know e to the x plus e to the minus x over 2 raised to the minus s dx. Then here 1/2 minus infinity to infinity. Now here 2 here minus s, so we can write 2 to the s over e to the x plus e to the minus x raised to the s power dx. Okay, then here 2 to the s, here 2, so 2 to the s minus 1 integral minus infinity to infinity. Now e to the minus x we can write 1 over e to the x, then if we take the common denominator here e to the 2x, so we have e to the s times x over e to the 2x plus 1 raised to the s power dx. Okay, then I'm going to use a trick. So here minus infinity to infinity. Here e to the sx over e to the 2x plus 1 raised to the s times. Now I'm going to multiply with d by dx e to the e to the 2 times x, e to the 2 times x. So we know the derivative of e to the 2 times x is equal to 2 times e to the 2 times x. So e to the minus 2 times x over 2. Then we know this both parts get cancelled and we will have 1. Okay, then we can simplify a little bit. So here 2, so here 2 to the s minus 2 minus infinity to infinity. Now we have we can simplify like e to the 2x raised to the s over 2 minus 1 over e to the 2x plus 1 raised to the s times d e to the 2x. So we are integrate with respect to e to the 2x. Now we know this is just a beta function, so we can write 2 raised to the s minus 2 beta of s over 2 comma s over 2. Here 2 raised to the s minus 2. Now we know relation between gamma function and beta function we talked about many times. So we know here gamma of s over 2 times gamma of s over 2 over gamma of s over 2 plus s over 2 we know gamma of s. Okay, then we need to simplify. So here 2 raised to the s minus 2 times gamma of s over 2 over gamma of s. Then here we have gamma of s over 2. So I'm going to recall the legendary duplication formula of gamma function. We know gamma of m times gamma of m plus 1 half is equal to square root of pi times gamma of 2 times m over 2 raised to the 2m minus 1. Then instead of m, if we plug in s over 2, we have gamma of s over 2 is equal to square root of pi gamma of s over gamma of s plus 1 over 2 2 to the here s minus 1. Okay, then we can plug in here square root of pi times gamma of s over gamma of s plus 1 over 2 times 2 to the s minus 1. Okay, let us simplify. Gamma of s we know get cancelled. Here 2 to the s minus 1, 2 to the s minus 2, so 1 over 2 times gamma of s over 2 times square root of pi over gamma of s plus 1 over 2. Okay, this is the answer for our integral. We generalize, so we know now I is equal to cube root of 3 over 3, then 1 half square root of pi gamma of s over 2, s we know now 1 over 3, so gamma of 1 over 6 over gamma of s we know 1 over 3, so 1 over 3 plus 1, so 4 over 6, so 2 over 3, gamma of 2 over 3. Okay, now we have gamma of 1 over 6 and gamma of 2 over 3. Let's recall the Euler's reflection formula. We know gamma of x times gamma of 1 minus x is equal to pi over sine of pi x. Then instead of x, if we plug in 2 over 3, we have gamma of 2 over 3, gamma of 1 minus 2 over 3, we know 1 over 3 is equal to pi over sine of 2 pi over 3. So we have we can isolate the gamma of 2 over 3. We know gamma of 2 over 3 is equal to here sine of 2 pi over 3. So we have 2 pi over square root of 3. So we have 2 pi over square root of 3 times gamma of 1 over 3. So we have gamma of 2 over 3. Then again let's call the duplication formula of gamma function. We know gamma of m plus 1 half is equal to square root of pi times gamma of 2 times m over 2 raised to the 2m minus 1. We can isolate the gamma of m. We know gamma of m is equal to square root of pi times gamma of 2m over 2 raised to the 2m minus 1 times gamma of m plus 1 half. Now if we plug in 1 over 6, so we have gamma of 1 over 6 is equal to square root of pi times gamma of 1 over 3 over 2 raised to the 1 over 3 minus 1 gamma of 1 over 6 plus 1 half. Okay, let's simplify. Here 2 to the minus 1 we can write in the numerator 2 times the square root of pi times here gamma of 1 over 3 over here 2 to the 1 over 3 we know cube root of 2 times here we have gamma of, if we simplify, gamma of 2 over 3, gamma of 2 over 3. Well, now we know the gamma of 2 over 3. We find the value of gamma of 2 over 3 by using Euler's reflection formula. So we can plug in here 2 times the square root of pi gamma of 1 over 3 over cube root of 2 times. Now here we have gamma of 2 over 3. We know gamma of 2 over 3 is equal to 2 pi over 2 pi over square root of 3 times gamma of 1 over 3. Okay, now we can simplify here. We know square root of pi, here pi, so square root of pi get cancelled, and we have here square root of 3 over cube root of 2, here again square root of pi times gamma square of 1 over 3. Well, now we find the value gamma of 1 over 6 and also gamma of 2 over 3. So we can plug in here. Now we know I is equal to 3 times square root of 3 over 3 times 1 half the square root of pi, gamma of 1 over 6. We know here we have the value of gamma of 1 over 6. So we can plug in here square root of pi times square root of 3 over cube root of 2 times square root of pi times gamma square of 1 over 3. Then we need to divide by gamma of 2 over 3. So we have 1 over 2 times pi times square root of 3 times gamma of 1 over 3. Okay, let us simplify. Now we know here this 3 and square root of 3 times square root of 3 we know get cancelled. Then this is square root of pi get cancelled. So here we have cube root of 3 over, now here 2 times 2, so 2 square, here 2 to the 1 over 3, so 2 to the 7 over 3. So we have 2 raised to the 7th power cube root. Then here we have pi, so we have here pi. In the numerator we have gamma raised to the 3 power of 1 over 3. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.